Okay, now that we have reviewed the different types of Kubeflow components, the trade-offs between them, and how to describe a Kubeflow pipeline in code, the last step is to know how to compile the pipeline, upload the result of the compilation to the Kubeflow cluster, and create a run. The first step is to build and push all the containers that might be needed by the various components of the Kubeflow pipeline. These are not necessarily containers representing Kubeflow components. They can be ancillary containers that are needed by these Kubeflow components. For instance, this AI platform train component will trigger a training job on AI platform. That component, which is itself a container, needs yet another container, the training container, that contains the training code, the train.py file. And that will be run when you start AI platform training. AI platform training will first try to retrieve the training container from the registry, so that training container must already be in the registry before this component is run. So here we see the code to build and push the training container to the registry using gcloud build submit. Step 2, we build and push the base containers that are needed by all the Python lightweight ops. Remember, a Python lightweight op wraps a Python function into a base container. For that, we need to specify which base container to use. The wrapping of the code within the container is done behind the scenes, but we first have to push that base container to the container registry. Here, the containers we will use for our lightweight components need the Python packages Fire, scikit-learn, pandas, and kfp to be installed. We use the gcloud builds submit command to build and push the container to the registry. Step 3. We compile the Kubeflow pipeline, which means that we use the dsl-compile command, to which we pass the Python file that contains the pipeline description. Basically, the dsl-compile command will transform the Python code describing the pipeline into a YAML file, which can then be uploaded to AI platform. Step 4 is to upload the pipeline to the KF cluster. We can do that from the Kubeflow UI, or we can do it programmatically by using the kfp pipeline upload command line. In that case, we need to specify the Kubeflow cluster endpoint, which we can retrieve from AI platform pipelines in the command line. In both cases, the goal is to upload the YAML file that we have compiled and that describes the Kubeflow pipeline to the cluster. We can verify that the pipeline has been properly uploaded by using the kfp pipeline list command to list all the pipelines that have been uploaded to the cluster. Last step, how do we run the pipeline? We can use the kfp run submit command, which we need to specify the endpoint of the cluster to as before. We also need to give a experiment underscore name so that each run of the pipeline is organized into an experiment. It's like a folder where you can sort all of your runs. We need to provide a run underscore ID, the ID of the pipeline, and all the run parameters that we want to set. All these run parameters correspond to the arguments of the function that defines the pipeline in the Python file. Also, these arguments are exactly what you see in the Kubeflow UI when you create a run from the pipeline. Here we have the project underscore ID, the dataset underscore ID, the Google Cloud region, etc. Okay, lab time now.